Hello, everybody. Hi. All right. Welcome to Mobile DevCon. I hope everybody's having a fantastic day. I wanted to change pace a little bit. My name is Alan Canestraro. I work at Facebook, and I'm building a product team out here in London. And I want to change pace a little bit from what you've had today. We've spent the day talking to you about all the great things that you can add to your app to make your apps even better than they already are. But what I want to do is take a step back and look inwards and tell you about some of the things that we've done at Facebook to make our apps possible. I've been in app development for 13 years professionally, and 7 on iOS, 7. And I can honestly say that I've never seen any team move from concept to product, shipping product as fast as we do at Facebook. And I want to tell you about some of the things that we've had to change about our development process to make this possible on iOS. So let's get started. First, I'd like to talk about some of the history and how we got here. Then I want to tell you about some of the changes we've had to make from a team organizational structure and from a product cycle in order to get these apps out the door. Then I want to tell you about some of the tools that we use on a day-to-day basis to help develop our apps, to dog food our builds internally, and to make sure that our builds are stable and unit tested. And then I'll tell you a little bit about where I think this is going to take us going forward. So first, let me give you a little bit of history. The Facebook app, version 1.0, launched on the App Store on July 10th, 2008. That was the day the App Store opened. It was one of the first apps on the store, and it's a day I remember very well. And it was a native app, and it was written by one guy. And he went off, and over the course of a couple months, decided he wanted to build something for this new platform. And Facebook was a lot simpler then. So he was able to pull this off in a few months and shipped it out the door. And if you remember, it had most of what Facebook was able to had as a feature set at the time. But as time grew, Facebook grew, and we added a lot more features to our website, to our product, than we could keep up with on the iOS side. And Facebook had to rethink how we did this. So Facebook has a great background in the web. We came from the web, and so we thought it would be natural to, instead of write native code, do things in HTML5, because we could move faster, and we were very familiar with this. And so what we did, Facebook 4, was, for the most part, it was a UI web view hosted in an app that we then sent web content to. And there were a few things that we needed to bridge with the OS, things like image uploading or photo browsing. And for those things, we actually wrote a bridge that we could access via JavaScript using the website. But this had a few problems. Sorry, this actually had a few great advantages. The first being instant updates. And as you probably know, when you make a change on the web, all your customers get it immediately, no exceptions. It also gave us the ability to do things like A/B testing, right? We like data. And at Facebook, with the web, we can try different things, different experiences with different customers, and then see how engagement falls out of that. And it also gave us perhaps the holy grail of multi-platform software development, and that was the ability to have one code base across each and every platform. But HTML had a problem, and it had a few problems. The biggest one was performance, right? Before anybody could see anything when they went to the app, we had to download all the HTML for the page, including the JavaScript, that was the app itself, and all the CSS for layout. And only at that point could we display anything to the user. So our users perceived it as very slow. We didn't have a way of tuning to these multi-core devices that we now all had in our pockets. Also, we had to do a lot of hacks in our HTML to do things, to do DOM manipulation. If you think about our timeline, our news feed, it's an infinite scrolling feed. And in order for us to keep that performant, we needed to be able to remove newsfeed items and place new ones on as they scrolled on and off the screen. And with HTML, it becomes very difficult. And if you know iOS, you know that things like classes like UI table view make that very easy. In fact, they do it for you. It was also very poor for memory management. All our resources ended up getting loaded and kept in memory most of the time. Debugging was very difficult. Getting stack traces, the stack traces were very poor. If you've ever seen a crash inside of a weblog, it doesn't really tell you very much. And we were pretty limited in terms of animation and effects. Even though HTML5 has come a long way over its predecessors, it still was nothing like what we could do with native code. So a few engineers at Facebook decided that they were up for a challenge and they wanted to try and build native again. And the goal was, could they build something that was faster in native than it was with the web? And they had a very high bar. Remember, Facebook had grown significantly over the original versions of the iOS app. We added a ton of features, so these guys had to go and rewrite a lot of the features that we added on the website. And because this was an experiment, these engineers in this room couldn't disrupt the company with something that could potentially not ship. So these engineers moved to a war room. And if you don't know what that means, at Facebook, a war room is a room that's isolated from everyone else with all the computers and all the people that are required to make the project and all the snacks and drink. And occasionally we'd let in some air and some sunlight. But we basically sequestered these engineers to see what they could produce. It was a bit of a winding road. It didn't take just a couple months. It took almost a full year. But it led to some improvements and some challenges. One, we got a chance to rethink how we fetch data from our APIs on the web. Second, we got a chance to experiment with some advanced rendering techniques. We wanted our newsfeed to be very smooth. And in order for us to do that, we had to go deep down to core animation and do some things that were a little advanced. And as much as we didn't want to change anything from our previous version, this was an experiment to prove that we can build the exact same app faster. Designers like to sprinkle in things that make things prettier, and so the animation, if you're familiar with our app, when you can tap on a photo and it flies in, and then you can pinch and it flies back out, that was something that they had to add, and we did. Our engineers had to learn core data and core animation, which are fantastic frameworks, but very advanced and require a lot of time spent on them. So we shipped the app internally to our employees in mid-2012, and our employees liked it, and we decided it was time to get this out the door. So we sent it out to the public in August, and the reaction was very positive. The press loved it, but more importantly, our users loved it. We had about a two times perceived speed increase across the entire app, and our user ratings went way up. So we achieved the goals that we set out for. But now we had to figure out, how do we make this work across the whole company? There was one lesson that we learned very late in the product cycle. We got this product out the door, but a few engineers was not going to cut it. As we were developing Facebook 5, the newsfeed team wanted to come up with a new feed item type called Pages You May Like. That turned out to be very successful. The premise here was that we would suggest some pages to you with some advanced artificial intelligence. And an example of this is if you're from a small town and there's a sports team that a lot of your friends who are also from that town like, chances are pretty high that you're going to like it too, so we suggest that page to you. But the newsfeed team wasn't thinking about the Facebook 5 rewrite. And the Facebook 5 team actually didn't know about the newsfeed edition. But Zuck saw this and insisted that we go out the door. So a second war room was opened up, and this included some of the newsfeed team and some of the iOS team, and they went off and tried to figure out how to make it work, and they did it in a couple weeks. But it wasn't something that we wanted to reproduce. We needed something that was more sustainable. Because we didn't just have the newsfeed team. Facebook is broken up into different products for different features, like timeline and comments. And each of these teams had seen the performance benefits by moving to native code, and they had their own set of features that they wanted to add to the app. And the iOS team was starting to get overwhelmed. It was starting to become way too much for one team to build one app. We didn't just have one app, we had 5. So we restructured things into what I like to call the team sandwich. And the team sandwich has a few different layers. Down at the bottom, we have the core team, and they build the infrastructure that's used by the rest of the products. On top of that are the product teams. Now, the product teams are separate, but they build their product features based on the infrastructure from the core team. And there's another layer on top of that, and that's the release team. The release team's responsibility is to make sure that the product goes out the door stable. And the way we actually structure the release team, there are some dedicated release engineers, but we also have a rotation from each of the teams based on what features make it into the app. So we have a set of people that are just responsible for making sure that the app is stable and on time. And what used to be the iOS team, the dedicated iOS team, now became the core team. They were the most experienced on iOS, and they were the ones that were perfectly positioned to be able to write the infrastructure that would be shared across the rest of the application. And their job is to make sure that the app also stays fast and the code stays clean. So this is great. We were able to restructure our team to move fast. But now we had to think about our product cycle. In most teams, in most projects that you may have worked on, you tend to be feature-driven. You decide that your version 2 of your app is going to include features X, Y, and Z. Well, with the structure that we had with all of these teams, that meant that our releases were at the mercy of the slowest product team. And sometimes features get changed, right? We move quickly, which means we reevaluate frequently. And if a feature wasn't ready to go out the door, but it was scheduled to be part of that release, that means that release would have to get held up, which held back the rest of the features. So we took a note from Mozilla. And it should come as no surprise, actually, several ex-Mozilla employees and executives actually work at Facebook. And so they brought to us something that worked really well for them, and that's something called the fixed release cycle. And the fixed release cycle says, instead of shipping an app based on the features, you ship an app every X weeks, no matter what. And at Facebook, we've experimented with some different times, and we've landed at 4 weeks. And what this 4 weeks breaks down into is we start the 4-week cycle by taking a tag of our master branch. And that tag for the next 4 weeks will be spent stabilizing. In fact, the first 2 to 2.5 weeks are spent fixing bugs and making sure all the features got integrated properly. And the last week and a half is something we call the soak period. And the soak period really ideally is when we don't touch anything. And we want to understand what bugs are there, and sometimes we have to fix ones if they're serious enough. But really, we just want to know that the app is stable and we can catch any last issues. In order for us to do this with these product teams, we require that the product teams build their features with an off switch. And that means if we decide during the release cycle that that feature was not ready, or maybe it destabilizes the build, we turn the feature off and we can try again in the next release. And frankly, the product teams are pretty happy with this, because if they're not ready, they don't have to wait 4 to 6 months for their feature to get into the next release. They wait 4 weeks. And the way we do this is we ask them to build them in with pound defines at the very least, but ideally using runtime switches. And I'll explain a little bit later about how that becomes even more useful. One place where this saved our butt was the new like bar. If you remember our old version of the app, it's what you see on the left. It has like, comment, and share in little text that you can tap to like, comment, and share. And the design team came up with something that was a lot prettier. In fact, they tried it out on the mobile web first and found that a lot of people were engaging with it much more frequently. So the result then is what you see on the right. And they built it with an off switch. And we had a bug. The bug was that, see those 3 likes, 1 comments right above the like bar? That tells you how many people have previously liked or commented on this post. They weren't able to resize the feed in time. They needed a little more time to make that work. And so Zuck saw this and said, we can't ship like this. This was just a few days before we shipped the version of the app. This was about 2 months ago. And we flipped it off, and pretty much nothing else changed, and we were able to go out the door 3 days later on time. And the next month, they fixed their bug, and we were back to this. Now I want to talk a little bit about the day-to-day. What do engineers do as part of their process? At Facebook, we have something called developer velocity, and that's a metric we use to measure how fast can we go from a concept to a feature that's shipped and in customers' hands. And we like to iterate quickly. And the only way we're able to do this is that while we're stabilizing our release builds, we are also able to experiment on new features. And we have one cardinal rule here, and that's you cannot break master. because there's nothing that slows down a team more than a broken build. In fact, we care about this so much that we went and printed a whole bunch of posters. This is part of the iOS team, printed a whole bunch of posters and put them up around campus to remind people that they should not break master. And in order for us to do this, there's a few things that we had to do to the engineering process to make sure that our master is always solid. First, so engineers make their changes locally, as I'm sure you all do. But instead of checking right into the master branch, we have a little bit of a process in between. Engineers post their changes for review by the rest of the team. When they post their changes, our build bot goes and takes those changes, inserts them into the tree artificially, and then runs them to make sure that there were no build failures and that all the unit tests pass. While that's happening, team members, the rest of the team, can go and review the change and have a discussion about whether the change is right, if other people agree, if there's anything that they need to modify to get this right. And once the team is approved and we can verify that everything passes correctly, then it's time for the engineer to check in his change. Now, I get asked a lot, what source control system does Facebook use? And if you haven't heard this already, we use Git. And Git was designed for Linux, which has thousands of distributed engineers, and I don't know how much source code, but tons of source code. So it's designed to be very fast. And that's perfect for Facebook's code base, because we have a huge code base. But another great feature about Git is it allows you to do nonlinear development. It allows you to have multiple changes at the same time. And if you know other source code management systems like Subversion or CVS, you frequently have to check out an entire version of the branch or check in your changes if you want to try something new. And in Git, each of these is pretty much treated like its own branch that you can jump between. Now, when you check in your changes, when you submit them for review, instead of going into master, it goes into a system called Fabricator. And Fabricator is open source, which means all of you can go download it and use it as part of your process. And what it does is it takes that diff and it creates a web page for every diff. And that web page gives you a few things. One, it gives you the before and after of the source code. It gives you a diff inline on the web page so you can go to one place to see what the change was. And it also gives you a discussion forum where the rest of the team members can talk about the change. And not just one global discussion forum for the diff, but it actually lets you do a line-by-line discussion forum. If somebody really has to say something about line 243, they can go point on that and insert a little discussion. It's pretty cool. So I want to show you what that looks like. This is Fabricator. I'm going to zoom in on the header here, and there's some things to note. The first one is the title, right? So this is my check-in. I'm fixing an accessibility problem with one of our views for visually impaired users. The change needs review. I'm waiting for my team members to take a look at the change. There's the author, there's the reviewers that I've asked to take a look, there's a number of lines, and below that is something that's extremely important, and that's the build status for each of the builds that we're running automatically. And you'll see here on the second line, I broke the build. I broke Facebook for iOS, that's the build, that's the app that you all download. So shame on me. So the next step for me is to go back and fix it, resubmit for review, and hopefully it passes. Not hopefully, I know what I'm doing. So a little bit below that, there's some more things in Fabricator. One, we see the start of the discussion forum down at the bottom. And then below that, something called a test plan. And the test plan is me saying, what is it that I tried to make sure that this change actually works? And then finally, we have the diff. So there's the source code and an example of an inline discussion for a particular line in that diff. And at Facebook, we're sometimes not satisfied by words, or sometimes images can speak a lot more than words. So we have something called image macros that engineers spend way too much time making, but they do. And this was a comment about the diff. In fact, the image macros tend to be so much fun, I thought I'd give you a little helping of them here. So the one in the bottom left tends to get used a fair amount. So, all right, so now manual review is not the only way that we have to check code. We actually have some automated tools as well that go and verify the quality of the code. One tool is called ArcLint, and this is also part of Fabricator, so part of the download for Fabricator is something called Arcanist. And in there's a tool called lint, and what it does is it allows you to set up scripts that will automatically run through the changes at check-in time, run through all the source code, and tell you if there's anything that the script catches. And this is great for things like, I've worked on teams that are very strict about style guidelines, indentation and braces. Those kinds of things are easily scriptable. It can also do things like warn against certain symbols, or it can check for certain pattern mistakes in your code and can even offer to fix them. So I want to show you just a quick example. Here's a block of code. And if you can read this, the first few lines is a method that basically goes and sets an accessibility trait on a view to tell the view that it's a header. The second block is a dealloc, where you release your instance variables. And so when I run this through ArcLint, this gives me a couple warnings. Actually, one warning and one error. First, the warning is about this accessibility trait that I used. And this accessibility trait is only available on iOS 6. And one of our engineers hit this bug several months ago where they used this trait, and on iOS 5 causes a crash. And everybody at Facebook likes to use the latest stuff, so we caught that one, but we would not have caught it if not for this lint rule that checked to make sure that you're about the symbols that you're using. And so as a developer, when I see this error, I know that I should go in and check for iOS 6 if I'm going to make this code, if I'm going to call this code. The second error it caught, and this one is actually an error, the other one was a warning, is that you're never supposed to call dealloc directly on anything except super. And what I probably wanted to do is call release. And the person that wrote the script knew that. And they actually set it up to propose the change for me. So when you have these kinds of changes that propose the correct change, all I have to do then is press yes, hit return, the code gets patched and resubmitted, and all is good. Now, I've seen some pretty creative lint rules. There's actually one in there that's saved my butt a few times, which is if you add yourself as an observer to the notification center, it checks to make sure that you've also removed yourself as an observer, and that's pretty handy. All right, so another tool that we use at Facebook is something called BuildBot. And BuildBot is what we use to check for build failures and unit test failures automatically. And the questions, what it wants to do is basically verify that everything still passes, and then it goes and it updates Fabricator with the results. Now, one of the great things about this, if I was to go and run all 5 of our apps through builds and run all the unit tests for every one of my check-ins, that's going to take me 30 to 40 minutes to run all that stuff. And sometimes you might be working in some piece of code that you think is pretty safe, but you've got some other app that's depending on the behavior that's going to break, or a unit test. Well, this, because it's distributed, will actually give you a result back in about 5 minutes and update Fabricator with the results. And that's all the apps, all the unit tests, 5 minutes, done. And if somehow you're able to circumvent BuildBot and still get your broken change in, you get a BuildBot failure email, and that tells you basically drop what you're doing and go fix your code and resubmit, or else you've broken master. All right, so I want to talk a little bit about how we handle builds at Facebook and how we dog food internally. We have lots of employees at Facebook, and all of them are faithful users of our products, I like to believe. And so there's no better people to be our guinea pigs on our version of the app than our employees. So we deploy to everybody. We deploy to everybody internally. And we do this by signing with the enterprise distribution profile. And if you haven't played with this, I highly recommend you go check it out. It's part of Apple's developer system. And what we do then is we code sign with the enterprise distribution profile, and we post these builds to an internal website. And every morning when our team launches the Facebook app, they get a warning that says, hey, you're running yesterday's build, go and update. They click on OK, they go to our website, they tap the link, and it's installed directly on the device. They don't have to do anything else, and they're always up to date. Another thing we do, this was a neat little trick that I didn't know of before I came to Facebook, which is that we use different bundle IDs for each of our types of build. right? We have our App Store build, which I always like to keep on my device in case there's anything weird with the daily builds. But I also need to have the daily builds on my device to make sure that I'm testing it on a day-to-day basis. And of course, I'm an engineer, so I'm building and I'm installing every few hours new changes that I've made. But sometimes those changes are unstable and I need the other versions side by side. So by tweaking the bundle IDs, you actually get to install multiple versions of your apps side by side. Here's a screenshot from my iPad, and you'll see I actually have 4 different versions of the app installed on my device. And we've actually gone and changed the icon for each. And the bottom right corner there, that's our golden master. That's the one that's about to get shipped to the App Store. So it's got the little gold leaf around the edge, which is kind of a cute little addition. And another thing to notice here is one of our engineers for a hackathon thought it would be really handy to have the build number embedded right into the icon. So if you report a bug and you need to find out what the build number is, you don't have to go into the app, open up settings. And what if you've got a build that's just crashing on launch? You're screwed. There's no way to tell the build number. It's on the icon, really easy to find. Now, as far as branching goes, I've talked a little bit about this. We have 2 branches that run concurrently at all times. One is our master, and master is where all our experiments happen. It's where all our feature development happens. But it's also where all our stabilization happens, because as our release build is running, we check everything in the master first, make sure it works there, and then the release team goes and uses a tool that I'll talk about in a moment called Relief that pulls those changes automatically into the release branch. And so Relief, again, part of Fabricator, open source, just open source about a month ago, I believe. And it's a tool that's specifically meant to manage this workflow. It's meant to merge changes from a master branch into a release branch. And the way it works is, as an engineer, when I've made my change and I submit it to master, I can then go and nominate that change for the release branch. Then the release team that I told you about earlier gets their set of nominations on a dated, well, as the nominations come in, they make a decision whether they want to take it or not, and press one button, and it automatically gets merged into the build. Here's what Relief looks like. A few things to note. So when the release engineer sees this, they have to make a decision. They have to make a call as to whether this is going to be safe and whether this is going to add to the quality of the release build. And so there's some metrics here that we have. One is the size, which is the top of those 2 bars. And in this case, it's, what, a 10-line diff, right? You can imagine a 10-line diff is probably has a higher chance of being stable than, say, a 1,000-line diff. So if that bar is nice and full, they may want to do a little more investigation before they pull it in. Below that, there's churn. And churn is not a metric to do with the code itself, but instead, it tells you how much back and forth happened in Fabricator between the engineer and the rest of the team to discuss the validity of that change. You can imagine if the engineer posts his change and it gets rejected and he posts it again and there's 12 comments talking about whether this is the right thing to do, there may be something worth looking at, and this is really easy for the release team to tell that there was that much discussion. On the right here is something that's really interesting. It's called karma, and engineers never get to see their own karma. And it's a discretionary metric that the release team basically gets to give you and take away little stars based on your performance in helping the release team. There's one engineer who, it was about 5 p.m. the day we were going to make the cut for our release branch, rushed in a change and broke the release build, and the release team took away his star. And the next month, he felt really bad about it and worked really hard to help them stabilize, and they gave him his star back. So just like grade school, but sometimes that's how you have to deal with these people. So anyway. All right, so the last thing I want to talk about is how we test the app. Right. So Facebook, we have, I've talked about how we can manage experimentation and stabilization at the same time. But ideally, we don't want to have to spend the time to stabilize. It should always be stable. And so we work towards that goal with some rules that we have in place. So we don't have test engineers, right? Some teams I've worked on in the past, As an engineer, you write the code, you ship it over the wall, and then you have QA go and try things out, and hopefully they find the bugs, and then they send them back to you, and you have to make a decision as to what's going to get fixed or not. We don't have QA departments, and we don't have test engineers. But what is in Facebook's culture is high-quality apps and reliable user experience. And so in order to enforce this, we rely on our engineers to include developer-authored tests. Now, if you're not familiar with unit testing, it was popularized about 10 years ago. It's been around a long time. About 10 years ago, there was a book called Kent Beck called Test-Driven Development. And the idea, the philosophy behind this is that when you write code, you know what your inputs and outputs are going to be. You know what your methods are going to be. And so instead of going and writing that code, you write the tests that verify that code. When you run those tests, it's going to fail because you haven't written the code yet. So then you have a failing test. You go ahead and you write the code and you iterate the minimum amount of code required to make that test pass. Okay, now you have code that works, but it's not pretty. So you can go and clean up your code, you can go refactor, you do whatever you need to do to make the code pretty and to stabilize. But because you have that test that's passing the whole time, you know that your code is high quality. And what this does is it doesn't just help you test the code that you're writing. It helps you build up a library of tests that will run across your entire code base. And it helps you limit future defects in this way. In fact, it catches problems so early that your code, your bugs, don't even make it into the code base. They never even make it past Fabricator, and your code stays stable throughout your release process. So unit testing on iOS is actually pretty easy. If you haven't played with it, it's just a checkbox in Xcode when you create a new project. And what it does is it uses OC mock and send testing kit. It's well documented. I encourage you to go check it out. It uses the dynamic nature of Objective-C to help you insert these mock objects to pretend that they're the inputs and outputs of your classes. But unit testing on iOS is not ideal. Some of the frameworks are immature. There's no good dependency injection, and UI automation can definitely use some improvement. But more so, iOS engineers, this is just not part of our culture. Unit testing is not something that we learned as we learned iOS. And there's some other problems too. Xcode build, which we rely on very heavily in order to do our continuous integration system. Our build bot relies on Xcode build. Xcode build doesn't know about your test action in Xcode versus your run action, which is what you use as an engineer. So your schemes get kind of dirty. Also, Xcode build, again, part of the iOS SDK, doesn't run the tests that require the simulator. And for us, this is a huge problem. And in true Facebook fashion, we decided to fix this problem. And very, very recently, we wrote a new tool called XCTool. And XCTool is based on Xcode build. In fact, it's syntactically the same. If you're familiar with Xcode build from the command line, it's the same. And it solves the problem of test and run schemes when run from the command line. It also solves the problem of running tests that require the simulator. XCTool will do that. And it gives you structured output. And if you're using Fabricator, we've already done the work to make it look right in Fabricator and give you some pretty output. But because it's structured, you can go and customize it for any other build system you use. If you use Jenkins or TeamCity, those are easy ports from a JSON structured output to whatever those tools take in. In fact, we even made it easier from the command line. If you've ever used Xcode build, if you've ever built from the command line using Xcode, this is what your output looks like, and that's for one file that's successfully built. Well, what we did was we took the output, we made it a lot prettier, and this is what XCTool spits out. Those were successfully compiled files. There's one warning, which is super easy to catch, especially by scripts. And XCTool is available today. We just open sourced it this morning, and the URL is down at the bottom. So if you require unit testing and a continuous integration system, this is the tool you need. Thanks. I didn't write it, but I'll take the applause. All right, so there's some other tools that we have for testing, for internal testing. One of them is something called Rage Shake. And Rage Shake is great. When our employees find a bug, they take their frustration out on their device and they shake it up, and we use the accelerometer to tell it what they're really trying to do is report a bug. And at the time that they shake their device, we collect some things. One, we take a screenshot of what's on the screen. We gather the last 10 seconds of network logging. We get the last crash log. So if you crashed and you relaunch and you give it a shake, we'll actually get that as well. We get the last 10 seconds of NS logs, and we even dump the view hierarchy. And we package all that stuff up, and we send it to Facebook in a task that an engineer gets and knows to go fix. The dump the view hierarchy I want to call out is really, really handy. This is something I used to use a lot. I use a lot. And it's if you call from your GDB debugger, UI application, shared application, current window, recursive description, it'll actually give you this great log of every view that's on the screen. And if you haven't used it, use it, please. Go look it up if you didn't catch what I just said. But it's been great. So another great thing about the Rage Shake, because you're shaking the device and you're not touching the screen, you're not interrupting anything that may change if you have to have some gesture, right? If your view state is really sensitive, the bug is really sensitive to the view state, all that stuff gets captured without touching the screen. Another super handy internal tool that we have for testing is something called internal settings. And if you haven't included something like this in your app, I would definitely go and encourage it. Our debug builds of the app have and our daily builds have an internal settings panel where you can go and turn on and off features, right? If you've built your features in such a way that they have a runtime switch, this is where you can go toggle it on and off. But it also gives you some places to, let's say, change parameters. Let's say you want to tweak some timer or you want to tweak some values. You can do that here without having to rebuild all the time. This is super handy. And we've talked a lot today about deep linking. Well, we deep link a ton in the Facebook app. And so if I were to scroll down a little further in our internal settings, there's basically a little control panel that lets me trigger a whole bunch of URLs so we can make sure that we're deep linking correctly within the app. So that's where we've been. And those are all the changes that we've made at Facebook in order for us to be able to move fast. Right? That's our overarching principle, is that we want to be able to move fast from concept to product. And we've set up